Welcome to our CST PhD seminar. Today, our guest is Severin. He has a bachelor's degree in physics, and then he came and he's starting PhD program with our department, University of Louisville. Previously, after finishing bachelor's degree, he was software engineer at Intel, and also machine learning intern at Lawrence Livermore National Labs. Also, he was at Cambridge AI Fellow, I assume Cambridge in UK Fellow, and his research is oriented toward understanding language models and AI safety, including recent work on deceptive alignment and interpretability. Severin, welcome to our seminar, and the topic for today is, even the title is very challenging. Why do AI experts disagree about existential risk? Your time.
Okay, yeah, thank you. So my title slide shows the face of Dr. Yampolsky and Jan LeCun, who are both AI researchers and both pretty well known. These are like screenshots from the Lex Fridman podcast, if anybody's seen the Lex Fridman podcast. It's like a big podcast, and he talks about stuff like AI. And a lot of researchers recently have come forward, like Dr. Yampolsky, and said like, hey, AI could be like really scary. It could like kill everybody. It could be like an extinction risk. And like, I'm kind of like, what's going on here? Like, why does one of you think there's like a 99% chance of extinction and one of you think there's a near 0%? Like, what's going on here? Like, one of you has to kind of be wrong. And why is it that some people can be so worried and so concerned and some so unbothered? And like, can we as AI researchers, like I'm kind of new to science, but like, can we as like scientists present some actual like cogent sort of consensus, sort of clear view about like, is this existentially dangerous? Are there risks? Is it totally safe? Like, this seems a little unacceptable to me. So yeah, and only one of these two came to my talk, so thank you, Dr. Yampolsky. Though I have met Jan LeCun, and
But did you invite him to the seminar? That's the question.
I didn't invite him to the seminar, unfortunately. Well, he can watch the recording. But yeah, anyways. Yeah, most of my research is like technical research. It's on sort of, I'm interested in sort of like this overlap between like machine learning and game theory, and I will not present any of that because I think this is like more interesting and like deserving of more discussion and attention, and it's also just like more fun. So yeah. So like, what am I actually going to present to you? First, I'm just like going to give you a little bit of like background about like AI risk, why people like Dr. Yampolsky are concerned, why people like Jan LeCun are not. I'm going to talk about some surveys of AI experts to try to give you like some rough idea of what like AI experts believe. And then I did my own survey that goes like deeper than these other surveys, where I specifically try to answer why do we disagree so much about the risk. And so my survey, and I have a paper where I sort of steel man both sides, and I try to like get to the bottom of like, what is the crux? What is the disagreement? Can we agree on anything? Is there consensus on anything? And yeah, I'll explain sort of what I think the missing pieces in some of the other surveys are and what I think the gap I fill is. As background, in May of 2023, the Center for AI Safety released this statement. It's pretty unambiguous. It says mitigating the risk of extinction from AI should be a priority like nuclear war. So they're like pretty unambiguously saying, okay guys, we think like AI is as scary as nuclear war and pandemics. And then the caliber of people that signed this is like extraordinarily high, right? So we have like Nobel laureates. Geoffrey Hinton just won the Nobel Prize. There's Turing Award winners, which is like the computer science equivalent of the Nobel Prize. there's the CEOs of all 3 major labs, so people like Sam Altman. These are like the people who have been responsible for the most impressive technical breakthroughs in the entire field of AI. Also signing on to this statement, now apparently XAI is a frontier lab. The co-founder and founder of XAI also signed this statement. They're just not in my screenshot. So truly a massive amount of like experts, and again, the caliber of people signing this and, you know, saying that they're concerned is like extraordinarily high. Also going to give you a quote. I won't read this because it's a little hard for me to read from the side and you guys can read, so I'll let you read it for a moment. And, oh, I can read it. It's on my screen too. It seems probable that once the machine starts thinking, it would not take long to outstrip our feeble powers, and we should therefore expect the machines to take control. This was actually said by Alan Turing in 1951. So it turns out the sort of like conceptual founders of computer science, like Turing, Norbert Wiener, von Neumann, these people were like actually really thinking about these like philosophical thought experiments, like, guys, like what if we like extrapolate to some point where the like computers can outthink us or outwork us or be smarter than us? And so Turing thought a lot about this. Norbert Wiener also thought a lot about this and sort of has like famous thought experiments about this. And yeah, so this sort of concern dates back like, to the founding of computer science, really. On the other hand, there are some reasons not to worry. I showed you this big scary letter where the CEOs of AI labs and a bunch of scientists are saying, watch out. AI labs in specific are incentivized to exaggerate the progress that they've made, to exaggerate how risky or how powerful their technology is, because of course they stand to like financially gain from this. Some other machine learning researchers also have many objections. They say maybe it's too far away to be concerned. Maybe there's no clear path to build the thing that's actually dangerous with like what we have now, which looks like chatbots. The person on the front of my presentation who has a low p-doom or probability that we will go extinct also says that this kind of thing is fear-mongering. And again, I've shown that, I've shown the statement that shows Turing Award winners and Nobel Prize winners and top scientists, they're scared. This is also a very well-known scientist who still has a good reputation, and he's a leading AI scientist at Meta. I think, my talk is going to try to be less about like who's right and wrong, but it's going to be more about like, can we understand the arguments from everybody? Can we understand their perspectives? Can we understand the cruxes and like where they properly disagree and like what is that thing that's like missing between them? Because this is like a very big divergence in like opinion if someone's unworried and someone's existentially worried. And yeah, my goal is to like improve the debate here because it seems like an important debate. So next up, I'm going to show surveys. I think surveys are like pretty cool. Like we're like social creatures, and it's cool to like know what other people think. It's cool to like know what AI researchers think. And then yeah, actually before I show what other experts think, I have like a mini survey for you guys, which is just to answer the following question: when should we develop AGI? So I just like, this is not when do you think we will, it is when do you think we should. And AGI here I'm just defining as when should we build a thing that's human level intelligence? When should we build a thing that can do science and engineering better than us? And like, please, if everybody in the room could just like raise their hand when I call out the options, I'll give you like 40 seconds to think.
Before you ask what
Yeah.
how do you define AGI?
Oh yeah, like I said, it's something which is like human level intelligence. So
How do you mean? Human
Yeah.
level intelligence?
Okay, what I mean is it could do the work of a scientist. It could program as well as a human programmer in terms of like creating that output, like creating a large program, maybe with like intricacies.
It includes something like
math, can the AGI mean invent a new theorem?
Yeah, I think the way I would say, the thing the way I defined it in my survey at least, is can you do the same exact work that a professor would do? So like someone like you would do. Can you do the same exact thing that you would do? That's the criterion that I care about. So can you program as well as a computer science professor? Can you write a research paper as well as a computer science professor? That is the thing that I'm asking, when should we build that? And that's the cutoff line that I'm employing. So yeah, I'll let people think for like 30 seconds, but please, if everybody could answer, then I can compare your results to my survey results. So yeah. All right, does anybody think we should build my definition of AGI as fast as possible? Is there anybody that says as soon as possible? Okay. Okay. So this is a small room, so that's maybe like 20%. Does anybody think soon, but not as fast as possible? Like maybe we should have some sort of guardrails, but we should still try to do this fast because it's going to be like really good. No soons. Okay, so some as fast as possible, but no soons. Does anybody think like eventually, like, okay, maybe a couple eventuallys. I also raised my hand for eventually. Wait, I don't want to make this talk about my opinions. And then does anybody think never? We should never, ever build this thing?
I think never, yeah. They should never do it.
Okay. So then a couple never. So actually it's like fairly balanced. And this is more balanced than my survey, because in my survey, things were not so balanced. There was a heavy leaning towards eventually, especially among AI safety researchers. And then when I surveyed people like academics who were professors and PhD students, they also leaned towards eventually. And people in industry, so in companies like Meta and Google, tended to say sooner rather than later. So yeah, and they were asked just the same exact question as you, provided the same exact options. That was just a literal question for my survey. Though, now before I actually get into the meat of my survey, I'm going to talk about other surveys. So that was like a mini aside. There's a bunch of surveys. We can survey a bunch of different types of people. There's a bunch of surveys on the general public. Are they concerned? What are they thinking about? There's surveys on policymakers. These are like arguably the people that really matter a lot because they decide what we're going to do and what we're going to build. There's surveys on AI researchers, activists, engineers. I'm sort of interested in, and my project is interested in, the bolded groups. So specifically what they think and where they differ. But I have read all the surveys on all of these groups, and I've also like written up what all these groups kind of think and how they've evolved over time. And that's something that I can share at the end. The next slide is a lot of text, but I'll just tell you what it is before I show it to you. It is every single survey that I can find that asked when we will build AGI, so what people's timelines are. So this is every single survey I could find about that. I guess the interesting thing is here that they go down. Yeah, as time progresses, as surveys progress, people expect that AGI is coming sooner and sooner. Yeah, one or two of these are not surveys. These are like, a couple are prediction markets, but I list where I got the survey and then how many people were surveyed. And then I also plotted that same data where the bubble size is the sample size. So nothing too crazy here, just timelines are going down. People are expecting this to come sooner and sooner. Also from another survey, from the AI Impacts Survey, another thing that inspired this project was this concern that the median AI researcher expects there to be a 10% chance of extinction. So that means if you pluck a random AI researcher, they are sort of thinking like Russian roulette odds. And if you, take some researcher over here, like Dr. Yampolsky, you're taking like much worse than Russian roulette odds, like almost guarantee or guarantee. And then you may occasionally find AI researchers who say this will be extremely good. But the median is 10%. The median AI researcher is saying 10% chance of extinction. Again, this is not my result. This is a result from the AI impact survey, which is like the biggest survey on AI researchers.
How do you read this graph? I don't think I understand how to read
Okay. Oh yeah, this is a confusing graph. So each participant has like these little sliders where they're like, you rate your like percent likelihood of each event. And so like you'll say, oh, I think there's just like 100% chance of an extremely good outcome. Or you'll say like, I think there's like a 10% chance of a good outcome, 90% chance of a really good outcome. And you just adjust these little sliders. And so each line is a person. And so yeah, the median is like right here. And the median, extremely bad outcome scenario is 10%. So the takeaway is really just the one-liner of, okay, the median AI researcher thinks 10% chance of like extremely, extremely bad thing happening. So I'll show you one more result from like other surveys before getting into mine. Dr. Yampolsky wrote up a list of all the arguments to not be worried or to be unconcerned or to think, AI safety research is unnecessary. And then he clustered all of these arguments into like different categories. So a reason not to be worried is a priority argument. Maybe you think, yeah, this is important, but like something else is more important, like maybe climate change, or it's too far to worry about, something along this axis. Or you could be unconcerned for like a technical reason because you think it's like too technically challenging to build this thing that's dangerous, or that we're not on the correct technical path. These are the type of reasons that you could be unconcerned or like unbothered or unworried. And I found these interviews led by someone named Dr. Vale Gates, where she interviewed like 50 AI researchers. She presented the arguments for like, why might you be concerned? And then I took those interviews, I transcribed them all, and then I used Claude, which is like a ChatGPT alternative, which I recommend over ChatGPT. I can explain why at the end if you want. But I transcribed them all, ran them through Claude, and saw which arguments matched up with arguments from Dr. Yampolsky's table of arguments. And it turns out the most popular arguments were these like priority arguments. The second most popular were like technical objections. And to be specific, the most common objection was, we think it's too far away, that's why we're not concerned. The next most common reason for like not engaging with these arguments or like not believing in them is like, we don't think there's a clear path to build AGI from present day AIs. And then the third most popular is, others are not concerned. So what do I think is missing from all that, all those other surveys that I just presented that sort of like laid the groundwork for inspiration? One, I don't think we know what AI researchers find to be the most persuasive or like convincing or true arguments for and against AI safety. I don't think we have properly characterized the areas of consensus and divergence between AI experts. So we don't have consensus between those who are unworried and worried. Like maybe they agree on a lot. Maybe they agree on policy ideas, even if some are pessimists and some are optimists. And we also don't have any data on how familiar people even are with AI safety research. And then finally, the name of my talk, we don't know why some people are worried and some are unworried. Like, we haven't like distilled this down and like done a proper analysis of like, what is the crux here? What are people missing? What are the majority of people missing? And yeah, like I mentioned, I did that whole interview transcription thing. That kind of gives a bit of an answer to that, but not a full picture. And so I wanted to run a full survey. So here's what I actually did. I assessed people. How familiar are you with AI safety? What's your stance on it? So are you, concerned, unworried, somewhere in between? And then I had people read something. So like read an excerpt from an article. And the article was either like a mainstream media piece or like a very concerned piece, just a couple pages, which was essentially an argument. And then I saw how they reacted, and I saw if that updated their beliefs. The people that I surveyed were mostly academics, so mostly like PhD students, mostly like professors. And then there were like a couple AI safety researchers and people in industry. The way that I got these was pretty simple. I went to like the largest machine learning conference. I scraped a bunch of emails from the papers there with like some AI tools, and then I found a bunch of emails and sent it to like 2,000 people, and 111 responded. So yeah, the criteria, the cutoff is you're either a master's student, a PhD student, or a professor, or you work in industry and you have a published paper at a top machine learning conference. So this is why I'm saying, well, I'm surveying experts on AI. Something that emerged in my data was 2 clusters, and this sort of emerged over and over again. When I asked people what they believed in, whether they agreed or disagreed with statements, I found that beliefs in these things were highly correlated. So the idea is that future AIs will be tools, things that like don't have goals, and that the risks are overstated, and that we can just turn off AIs even if they're sufficiently advanced, even if they're perhaps smarter than us. Whereas on the other hand, the concerned category sort of like correlated with these type of beliefs. Beliefs like, well, self-preservation drives might emerge when you have an intelligent enough system. Or that technical researchers should be worried about catastrophic risks. And the way that I like describe this divide is I introduce this way of thinking about this divide, which is some people think of AI as like a tool, like a machine, whereas others think about it as like an agent or a new life form, something that's like grown and is autonomous and has goals and might develop self-preservation, whereas the tool group sort of sees AI as this controllable tool. It's sort of like other software without internal goals, and it can be like shut off if we want it to. And so like the specific beliefs that is correlated in my survey were like, you see it as comparable to other software. If you're in the tool group, you have a preference for shorter timelines, so you want AI to be developed quicker. You have less familiarity with like the philosophical AI safety ideas. You believe, or participants believed, if they were in this tool group, that catastrophic risks are generally overstated. And then the agent group sort of views AIs as maybe, sorry. Did I go? No, I went too far. The agent group sort of sees AIs as more comparable to like a species as opposed to like just another tool, and they tend to speculate about future AI risks as opposed to worrying about current ones. So yeah, and like I mentioned, the way that I sort of arrived at this group was just like this grouping was sort of just like this machine learning clustering problem. What beliefs are correlated with each other and what beliefs are anti-correlated with each other? And this was just a divide that kept on cropping up in the data, that some people see AI as like this, tool which is like other technology, like code, and we can control it, whereas others see it as like, okay, it's like a thing that like takes actions and will eventually emerge as like uncontrollable. And I think a better way of seeing this is actually not like a tool versus agent perspective. It's actually like an engineering versus philosophy mindset. So whereas the engineer might look at AI as a tool and have this like empirical mindset, be very familiar with like engineering tools like transformers. They know the ins and outs of how AIs work. They have this like bottom-up thinking, and they're focused on current problems. So AI safety to the engineering mindset folks would look like, oh, we are worried about bias, we are worried about things like deepfakes, whereas the philosophy approach sort of does this looking forwards and is less concerned with the current state of the art and the current sort of engineering way of things, but is more concerned with intelligence itself, is more abstractly future focused and thinking about the limits of advanced AIs, which aren't necessarily here yet. So yeah, the engineering approach is essentially being empirically driven and drawing experience from present or current ML systems. The philosophy approach is like, well, what's next? And the types of risks that they're thinking about is completely different, right? Deepfakes is a very different concern than, smarter than human intelligence taking over and disempowering people. Or just generally some general intelligence outthinking humans. These are like very different risk models, and they both can be true and both make sense. So one of my findings was that very few people are actually familiar with the literature on alignment. What I mentioned earlier with my quote, some of these concerns are have been thought about since Alan Turing and by people like Norbert Wiener. And it turns out very few people are very familiar with the literature. So my survey, a big part of it was, can we assess how familiar and how literate and whether people have engaged with the seminal works in AI safety? Even for machine learning researchers, the answer is often no. And on top of that, the people who were very familiar with this, with the seminal works in AI safety, with alignment type stuff, were much more concerned and much more likely to have the agent sort of mindset. I realize I should define my terms. Instrumental convergence is the philosophical idea that, well, I think I define it actually. Yeah, this may be a better definition, that intelligent agents, regardless of their goals, will sort of converge at certain sub-goals. So things like, self-preservation. No matter what your goal is, you'll probably develop a self-preservation drive because it furthers whatever goal you have. And this is a philosophical idea. It's not necessarily an empirical machine learning idea, but it is popular in the AI safety literature. So, yeah, I'll let you read these actually if you want. The other two, there were 3 or 4. There were 4 things that I assessed how familiar people were. The last one is this thing called coherent extrapolated volition, which is something you would only know of if you've really deeply engaged with AI safety maybe. And it's just a simple argument, this philosophical idea that as opposed to wanting to steer AIs, super advanced AIs towards our goals, we should instead be skeptical of our own values and want to steer AIs towards what we would want if we were more ethical and wiser and smarter. Yeah. So yeah, I wanted to see how familiar people are with these ideas, and they were pretty unfamiliar with them. Like I mentioned, almost none of the people had heard of instrumental convergence. So when I ask people, how familiar are you with this? And they choose on a multiple choice slider, they've either never heard of it, or they're an expert at it, or something in between. Most people had never heard of a lot of the alignment terms. And I also asked how familiar people are with empirical terms, so these like engineering terms, and people were much more familiar with these. Though I included some very difficult ones like Markov random fields. I'm not sure what those are, but many of my survey participants were, as they were like experts in machine learning. The only thing to mention here was like I gathered all my like terms, and like for assessing familiarity, I wanted to like gather terms in like a structured way. So the way I did this was looking at classes of varying level. So the hardest terms were taken from the most advanced classes at Stanford in machine learning, and these were like titles for a week of study. Whereas logistic regression is like the title of a class that's like very introductory, or the title of a lecture of a class from a very introductory machine learning class. These terms were like collected in a similar way, but like from books. And I write about like how I arrived at these terms to like assess familiarity in my paper. This is like a confusing graph, but really it's the same thing as this. The point here is just like most people have heard of the engineering ideas, but most people have not heard of these sort of philosophical safety ideas and are just unfamiliar with them. And so yeah, like you can see, pretty much the only people that are like have a high familiarity with things like instrumental convergence are the AI safety researchers. They're maybe like reading more philosophy. However, they're like actually less familiar with some of the empirical concepts. So again, they're maybe doing more like philosophy work than empirical computer science work. Though they were like, they still understood some of this stuff. Academics were like more likely than industry people to hear about these like alignment ideas, but still not very likely. And all of this just sort of suggests that people are like not very familiar with alignment and AI safety research and concerns. The other big result, which I sort of pointed to earlier in my slides, was that some beliefs correlate much more strongly to concern than others. So the people who had heard of these terms, heard of these like AI safety terms, like instrumental convergence, were much more likely to adopt the AI as an agent type beliefs. And this is just a correlation heat map. So a lot of the thing in my paper is just, can I look at correlations between a bunch of beliefs and what are most highly correlated and what are most highly uncorrelated. And it turns out that being familiar with some of this like literature is highly uncorrelated with, viewing future AIs as tools. Here's a much more clear takeaway, since that graph is like confusing. People who are less familiar with alignment are like less concerned. This seems like pretty good empirical evidence for me. And most people are very unfamiliar with the alignment literature, so there's a lot of seminal works. And like I mentioned, people like Norbert Wiener have been thinking about this for a while. Dr. Yampolsky has books about this. And there's like a whole branch of philosophy that sort of has thought a lot about this and like built up truly like a lot of scientific results, which isn't necessarily ingrained into the machine learning research community at this point. So yeah, I think that is like my big result and insight. The other thing I mentioned I was interested in is like, well, we clearly have some disagreements. Is there anywhere that we have consensus? And like, yes, there are some areas of consensus and divergence. Most researchers, even those who are like more optimistic or less concerned, think that catastrophic risk should be taken seriously. So almost 80% of the AI experts I surveyed agreed with this or somewhat agreed with this. Almost none of the AI experts I surveyed thought safety work slows progress. And interestingly, I thought this was like an interesting finding. 57% of all of the AI researchers I surveyed agreed with the statement, I'm just going to read it verbatim, some AIs now or in the future may be moral patients with their own welfare that we should care about. And I thought that was interesting. 57% agreed, and the majority of the remainder were neutral about this like question of moral patienthood. Finally, here's just a quote that I think illustrates this sort of like tool versus agent divergence. I let people like do this free response thing. So, someone with the tool perspective says, I don't think it's possible for LLMs to produce AGI. And then someone with the agent perspective sort of comes in and differs. And he or she is like, well, I think there's this misconception that we're talking about LLMs being these scary AIs. That is pretty much it. I wanted to return to these two. Both of these worldviews are actually somewhat coherent to me. I think this engineering versus philosophy divide helps understand both of them. Some are thinking about empirical ML problems like reducing bias, and some are thinking about this philosophical problem of machines outthinking us. And the engineering mindset is really powerful at understanding current systems, which Jan LeCun clearly does because he builds them. But the philosophy mindset is also very, very powerful at predicting what systems may be possible or may be coming in the future. And so I think these are both powerful. I think it would be wise to try to employ both of them. And it would also be interesting to listen to both of their podcasts. They both appeared on Lex Fridman, like I mentioned. So yeah. I've one or two more slides. These are people who helped me out. Dr. John Bliss, who's from Denver University, and then Nikki Pai, who's from the University of Warwick in the UK. And if you want to see my full paper, I have it on my website because it's been submitted to journals, but that takes a while. And here's what I did. There's my email. So yeah, if you email me, I will respond about any of this stuff.
Yay, thank you. Okay, I assume it could be some question here. Let's check. We have several of our PhD, but even not PhD, in general explanation. What do you think? And do you have any questions for our speaker today? I can't believe that there is no question.
I have a question then.
Roman.
So you decided to call the two groups engineers and philosophers. For the first maybe 50 years of AI research, it was all engineering.
Mm-hmm.
We knew what we are doing precisely, and then 10 years ago we switched to, I think, science. We now grow those models, we evolve them, and then we study them like scientists who run experiments to see what the model can do. Do you think it would make more sense to call it engineering versus science approach?
Yeah, I think that's I think it would be fairly accurate to describe how we're making AIs as science experiments where we don't really know the outcome, as opposed to engineering problems where, you know, like building a bridge, we know what's going to come if we, you know, do things right. So like, yeah, I actually thought about this, and these icons were, I should maybe give credit to this. This icon is actually like the great scientist icon from Civ. Oh wait, I messed it up. It should be reversed. This is like the scientist icon. This is the engineer icon. Yeah, I switched my icons, I guess. But yeah, I think that's perfectly fair.
But in your graphs, you are showing, that is what I understood. Okay, yes, these engineers, these doctors, they know a lot of regression, these things. What is missing? A little bit more philosophy. That is how I understood your presentation. So who cares about deep learning, MLL, and all these, you know, advances? Let's make orientation towards philosophy. Let's think about that. Will we destroy the world or not destroy the world? Will we? Why you think? Of course, in your case, PhD students or, you know, with scientific research, expecting that they know what is regression. And then you're asking some a little bit teeny question, you know, about some philosophical. Do you think you were a little bit biased in these surveys?
Yeah. So the way I tried to like do this is for the like AI safety philosophy terms, I wanted a term that anybody who had thought of it or taken any basic class about it would know of. So the easiest term was just AI alignment. If you had ever heard about this, that was my equivalent to logistic regression. And then from there, it sort of like got more difficult. So in the same way that like machine learning algorithms, you've probably heard of it, even if you're not an expert. I would expect that, you know, if you've thought at all about AI safety, you've probably heard this like term, the alignment problem. And then it gets progressively more difficult. The other thing is like, yeah, I actually totally agree with you. I think the like engineering approach is like totally important and useful and like true. I guess my like takeaway would be that these are like actually both very, very powerful approaches, and you might be best off as an AI researcher thinking about both at the same time. And I think that's like what a lot of the really top AI researchers are doing, right? They have like this incredible technical background, but are also like thinking about the philosophy approach, right? So like people like Sam Altman, people like Dario Amodei, people who are like at the top of the field are doing like both. So yeah.
What do you think? Is it some kind of noise, what's happening now, that you have experts and experts in AI? And they are experts, okay, they are maybe finishing one prompt engineering course with the ChatGPT, and they are experts. They are discussing about that. They know much better than all these professors, computer science, machine learning. They are experts. They use ChatGPT or whatever it is, Llama. How they are including that? Well, they are. They claim they are experts. They claim, okay, we are developing AI system. These who are using some deep learning, forget that. You know, everybody likes MLL. That means giving you the text, and that is AI.
Yeah.
What you are telling, true, false, or something similar, that is not AI at all.
Yeah. No, I mean, I like partly agree. You know, people who are at like the AGI labs, like OpenAI and Anthropic and DeepMind, these people are like not traditional academics maybe, and I think they borrow a lot from the like philosophy approach of like we think we're building general intelligence. We're not just trying to, do classification problems and so on, but also that is less grounded in like empirical evidence. It's less grounded in, it's previous research because it's just like it's something that hasn't been done at all yet. I don't know if that answers your question at all, but.
No, I don't expect exact answer. I'm just telling we have to be careful because I don't like sometimes we are trivializing even philosophy.
Mm-hmm.
And I will take one example, which is one of these Nobel Prize winners. And he gave one explanation, and I remember that, about young people who are going in high school, finishing high school. And he said, okay, you know what? You can go wherever you are, different disciplines. But if you are going in a medical school, don't go in a specialization of radiology. So try to go the other. So if that is a philosophy, I would not like, this kind of trivializing philosophy. I know why you tell that, I know what is a trend, but we have to be careful, what we are interpreting, as required philosophy or
Right.
safety, security in the AI domain.
Yeah, I mean, I think one thing to acknowledge is that there is like a decision boundary here, and that this is like a big divide, right? Like being concerned with abstract risks about future systems is like very, very different with being concerned with like needing empirical evidence from current systems. Yeah, it's almost like talking past each other. So, yeah.
There are some, yep, go.
So, I don't study AI, and to my current knowledge, the current AI systems are all pattern-based, and patterns are boiled down to mathematical concepts, which are represented as instructions which are run on a CPU,
Mm-hmm.
etc. With concepts that were once thought to be factual, like Moore's law, which states that transistors get twice as powerful and twice as small every 5 years or so. Those ideas are coming to an end. You probably understand this as well because physical limitations that are grounded in physics have to be, they provide hard deadlines that the universe just you can't go past. AI has to run on hardware at some point, and I'm really curious as to why hardware restrictions aren't being considered for AI limitations in any research that I've heard, perspectives from the engineering mindset, from the philosophical mindset. At the end of the day, it's software. It has to be run on hardware.
Mm-hmm.
It's not just a magic black box thing.
Right.
So what are your thoughts on this?
Yeah, I mean, like my personal thoughts are that like Turing machines and computers are like universal, and it doesn't seem like there's any reason to believe that whatever the human brain is doing couldn't be run on some arbitrarily long program on a physical, on like silicon. I don't think whatever algorithm humans are using to do science or philosophy or engineering is like unique to carbon brains. I think it could be implemented on the correct program on a computer. I don't know, is that?
Human brains, though, aren't clock cycle based.
Mm-hmm.
They're purely biological chemical reactions.
Yeah.
They have theoretical perfect, multi-threading or whatever you might want to call it.
Mm-hmm.
Computers and CPUs are bound purely by the hardware limitations.
Mm-hmm.
How many cores can you run a process on? And
Yeah.
the
Yeah.
current hardware that we have now, and even for the foreseeable future, anything that's highly advanced, you need a lot of processing power to even come near the high highest levels of computation.
Right.
So,
Yeah, I totally agree with your intuition, and like I don't have like any survey results, and this is like less about my project and more about my opinions maybe, but like my question would just be like, would it be possible to like simulate what the human brain is doing even on that like clock-based computer, silicon chip? Like, is it possible to emulate or simulate that and get the same outcome of something that can, do the job of a software engineer, or do the job of a philosopher, or like create something, even if it's patterns based? Well, maybe I could say the brain is patterns based, but I think at the end of the day, like I just assume whatever the human brain is doing, even if there's like specific architectures on a computer and it's clock based and like it's like structured in a like this intricately engineered way that it could like with the correct program do the same thing. And I guess that's more of like an intuition than but I think when like Turing was thinking about this, and like in his like big paper like on, I think it's like on computation and intelligence, he talks like a bunch about this and why he thinks like the computer is a universal machine and it can simulate anything that can be answered. I think this like question is like, his question exactly in that big paper, and like most of the paper, which is like Turing's most famous paper, is like on that question, and then like in the last 2 pages he like sort of describes the Turing machine and like the computer or whatever. Like that's like an afterthought, and like the bulk of it is this like sort of question of like universality of computing.
If I may add a little more specifically, so Moore's law is a specific small subset of a more general exponential returns paradigm. The single processor may come to physical limits due to the size of nanowires or whatever, but it's part of a bigger system. So if you look at the actual compute being used, it's growing faster than exponential, hyper-exponential. And this is within standard Van Neumann architecture. If we ever switch to quantum computers to anything else, that continues. We're always doubling, tripling amount of compute, so there is no limits anywhere close. You can always buy more compute if you have resources. What the connection here is that human brain is super tiny and efficient, so we can probably run all of human brains on the existing compute already. Emulations of those neural networks.
Okay.
So the question, whenever you were talking about doing this whole process, you were engaging in surveys and you were talking about, are you familiar with this word? Or are you familiar with it? I mean, some of those, I don't know, is a proper word, multicollinearity of sorts, were like, you may be less likely because you were just uninterested.
Yeah.
So is it possible that maybe this is more of a social science type question than it actually is something that would not even be something engineers, mathematicians would even consider an interest? Is that possible?
Yeah.
I mean, how do you feel about this being what I would claim is, it almost seems like this belongs in a social science department?
Right. I actually totally agree with you. It's just if we are going to like defer to machine learning experts for like how scared we should be about AI, then we should probably like have like a properly informed discussion and not talk past each other and like all have the same terminology and so on. I think one thing to point out is that people who just research machine learning are not necessarily always versed in like this philosophy stuff. And I agree, this is probably better labeled philosophy or social science than engineering maybe. But if we like as a society are like deferring to things like this, to surveys like this, to being like, well, AI researchers should guide us towards how risky this is, and then it turns out the AI researchers are like empirical machine learning researchers who haven't necessarily like engaged with the literature for like the reasons to be worried about like extinction, then like maybe we should rethink that. And yeah, does that make sense? Yeah, the only other thing for the intuition you had, I would also say there was like a talk by Ilya Sutskever, who's like the old chief scientist at OpenAI, and like this was like one of the first talks I ever saw by him, and he just said anything the human brain can do in 0.1 seconds can be perfectly emulated on a single forward pass of a 10-layer deep neural network. And then he like showed these like calculations that like the furthest an electrical signal can go in the brain in 0.1 seconds is 10 layers deep. So like whatever your quickest reflex is, that can be at least, you can have at least that smart of a system in a 10-layer neural network. And I think that sort of like served like, again, this is like maybe like more of like a philosophical thought experiment than like a, you know, concrete empirical reason, but yeah, I think that's where I like get my intuition from.
Do we have some more? Roman, I don't know, do you recall, it would be maybe 10, 15 years ago, when you had one presentation, I was asking you, is that something similar to religion? You know, I would tell, you know, what I'm looking here, it is not anymore one religion. You have two religions, and you don't have to prove any one. Do you like something? We will produce in this world everything very nice. There is no people that will be with ill, or everybody will earn whatever it needs or something. Or it will be the hell of this world, you know. These are, nobody has to prove anything. So everybody is how you are convincing, at least at the moment, you know. So yes, it will be very difficult to, you know, to make them much closer. You know, that is my impression at the moment.
Well, the predictions are we're 2 years away from the answer, so we'll see.
Okay, I agree. That is the question, you know. At the moment, we are just predicting. That is the reality.
2 years from what? What's the threshold?
From now, that it will be
some prediction.
that means essentially what I understand, development will be in this direction, that in 2-3 years you will have practical real data. Yes, that's very important, absolutely. And it is challenging, no question about it.
Yeah, I mean, I would almost like push back on being like this side is pessimistic and this side is optimistic, and be more like, well, that's almost a completely different axis. And then I think the axis that I really care about is not just optimism versus pessimism. It's like concern versus lack of concern. And lack of concern could be optimism, but it could also just be like unfamiliarity. So.
But what I don't like, you are interpreting not concern with you don't have enough philosophical analysis. That is what why not technical analysis? Why only philosophical?
I mean, I'm sorry for like. I feel like I've like leaned into like the engineering approach and been like, oh, this is like bad. I don't want to be like, this is bad.
That is something normal, you know. That is philosophical is something very worth.
Yeah, I actually think the engineering approach is like more valuable for understanding current systems, is the way I think about it. Is like, if you want to understand like how transformers work, how computer architecture works, you're going to like default to engineering, and this is like a totally good thing. Like understanding things from the bottom up is a totally good thing. I'm totally for that. And I'm sorry for like leaning into like, or like elbowing that group. My only point is really, I think we're kind of talking past each other. If one group is talking about deepfakes and bias, and one group is talking about philosophy ideas, like these are just orthogonal. Like we should get on the same page about both of these things. And I think that both are important. Like it's important to understand how transformers work. It's important to understand like Moore's law and engineering ideas. And it's also important to like understand where AI is headed and why some people are like concerned about that.
Maybe one philosophical question, if you like philosophy. are these two groups? Are they really interested to reach one or the other, or they like to be separated? If you are in some companies with expert in AI, you will scare them, and they want money and they are producing these new AI tools. Money is there. So why I would discuss with you security and safety?
Mm-hmm.
On opposite side, the same thing.
Well, that's a good question. So why do you think Sam and Dario, all of them signed that statement saying that, yep, it's going to be like nuclear war?
Yeah, I mean, I think both of these things are powerful, is like the correct answer. Like, I think you're very powerful if you can look ahead, but also look behind. Like, looking at the current systems, very powerful. Looking ahead, also very powerful. Turns out the people that do like both of these things at the same time are like responsible for like the biggest advances. And so like, I'm just like, well, imagine if you tried both of these approaches at the same time, and imagine how powerful you'd be then. And yeah. And I think that is like what they do, like Dr. Yampolsky said, like Daria Amadei and Sam Altman and people like this, and like Ilya Sutskever, the like biggest names in AI are doing both of these things, and they're doing them both like pretty well, very well. I mean, doing both, yeah.
Okay, that's good. Do we have some more questions? No? Severin, one more time. Thank you a lot.
Yeah. Well, thank you.